So what we're going to do now is we're going to show a case study that will demonstrate the performance of different collectors, non-concurrent collectors, concurrent collectors for different types of collections, essentially tree sets and hash sets and the concurrent variants therein. And you can find this particular example in the EX36 project in my Java 8 folder in my live lessons GitHub repository. So this is the key thing to remember. If you remember nothing else from this case study, remember that concurrent and non-concurrent collectors perform differently when we use them in parallel and sequential streams for different input sizes. And as you might expect, as is so often the case when we start dealing with parallel processing, the larger the value of n, the bigger difference we get with respect to the performance benefits of using concurrency. When n is small, it doesn't really matter. Typically, as n gets larger, then we get a bigger bang for our buck by using concurrency. And we'll talk later about sort of why that is in detail. Remember that non-concurrent collectors operate by merging subresults. So different threads operate on different instances of these intermediate result containers. And you can see here how if you've got a non-concurrent collector, then whatever type of mutable result container you have, be it a list or a set or whatnot, then it'll collect it in each thread into a subset of the list or the set or the map or whatnot. And then as the joining takes place, those sets will be merged together. In contrast, and this is very important to remember, concurrent collectors create one concurrent mutable result container and accumulate elements into it from multiple threads in a parallel stream. So there can only be one mutable result container, and it must be thread safe. So you can see here, unlike this approach where things are being done locally in each thread and then merged together by the parent, with concurrent collectors, there's only one collector, and the different threads in the parallel streams, common fork join pool, will directly add elements to that concurrent result container. Therefore, the big win, if it helps you in the right circumstances, there's no need to merge intermediate subresults. So we're going to take a look at an example here as case study EX36 that shows the difference in performance. And we're going to have some collectors that use the Java set implemented by a tree set or a hash set. And that will be done for non-concurrent collectors. And then we're also going to show how you can make your own concurrent collector, which we're going to call the concurrent set collector. And that can be used to merge things together, or not to merge things together, to accumulate into a common set that's a thread safe, synchronized set with better performance as n gets bigger. And the way we're going to do this is we're going to implement this using the concurrent hash map key set view, which is a variant of concurrent hash map that is a set, not a map, but it's implemented using concurrent hash map under the hood. And you'll see, as I have alluded to a couple times here, as n gets bigger, as we have more elements, we get a bigger win from using concurrent collectors. And you'll also see that you get a bigger win from using concurrency in general. So hopefully the gods of benchmarking will smile favorably on us when we show the example here in a second, and we'll actually get the right result. So here's the example we're going to look at now, and I will take a look at the code in the next part of this lesson.